Right. Today we'll continue with the remaining portions, that is linked list, trees, and stack and queues. Records. So I think records also we have to complete. We'll complete everything. The entire chapter will get over by today. Right. So can anyone give an example of record or what is record? You can unmute yourself and give the answer.
Set of fields.
Very good. Any other answer?
A record is a collection of fields.
Yeah, collection of field. Field is said to be a value. A value, it may be similar data type or not a similar data type. So that is what here it is different from the other things. Record is said to be what? Collection of multiple data type values. Here you can say it's a heterogeneous. It's not a homogeneous, right? So individually, if you see individual values for the different persons, if you see that it will be stored in a record, right? That it will be stored in an arrays, right? Individual arrays will be maintained to store the values of the individual fields, so that if you see individually it is said to be a homogeneous, but when you see collectively together as a record, it is said to be a heterogeneous, right? Fine. Now, in this record topic, so you may get a question like what is record and the representation of record in memory, memory representation of record in the part. We have to explain, you have to explain with a small example. And how the record is differs from the linear array. So as I told you, record is said to be a collection of different values, different data type values, right? That is a heterogeneous values are collected together and we are saying it is a record. And the second thing, it has been stored individually as an array. Say suppose here, roll number, batch name and your name, everything if I collect together, that is said to be a record. And individually if you see roll number, batch name, student name, individually if you see this, these are all maintained separately in a array. So this is said to be the memory representation. And how the record is differentiated with the linear array, if you see record, as I told you, record is a heterogeneous, array is a homogeneous. So this is in short answer I had given you. Let's see how you have to represent in the board. Right. So a record is a collection of data values, and each value is said to be a field, and the file is said to be a collection of similar records. So as I told you initial lectures, like field is the basic entity, and the next level is said to be a record, and that is a collection of fields, and next level is said to be a file, that is collection of records. Fine. So this is how it has been maintained. The level of hierarchy has been maintained, and each data item, it can be divided. It can be a group or a sub item also. And see here, these are the ways that you need to explain what is record, right? And this is an example like how the exactly the record has been stored in the memory, the representation of the record in memory. As I told you, roll number, batch name, and the student name. Here I have taken some other example like name, city, pin code, and phone number. So each and everything, if you see, it has been stored in a linear array, right? So it is not a non-linear data structure. It is a linear data structure, right? But while retrieving, if you see, it is taking the values in different places, so it is not considered as a non-linear. how it is stored, if you see, it is stored in a linear format. So linked list and the record and everything are coming under linear data structures, but it follows heterogeneous while retrieving, and it collects the values from the different memory location. That is the other part, right? So record is said to be what? The collection of these values. So this entire collection, say suppose here there are some values, so entire collection set of this particular thing is said to be what? A record, right? So this is record 1. Likewise, there are n number of records will be maintained. So this n number of records are collected together. It is said to be a file. And a record, it may be contains of non-homogeneous elements, that is different set of values. That is what I said, heterogeneous, right? As per the example, if you see, uh, example, if you see name, city, pin code and phone number, so everything it will be a different data type. Name, it is a collection of characters. City, collection of characters. This is numbers and alphanumeric. And the phone numbers, it will be character integers, right? So the different data types will be collected together. That is said to be a heterogeneous, and you can say non-homogeneous as well, right? So different data types. And array, it consists of homogeneous data. That is what I said. Individually, if you see, it is said to be a homogeneous data. And in a record, the natural ordering of the element is not possible. So that is what, individually, if you see, it is maintained in an ordered way. That is in array. And elements of the record are referenced by the level number. So individual record numbers are being maintained with the level number, so that it is said to be a reference of the particular record. So while those of the arrays, it can be referenced by indexed and set consisting of the n consecutive numbers. So there will be n number of elements, and which will be, it will be defined from 0 to 1 or 0 to n or 1 to n, 0 to n minus 1 or 1 to n, right? So these are the following points that record, it can be a different from a linear array. So there will be a 3-mark question. What is record? So this entire thing you need to write, and how record has been stored in the memory. That is memory representation of record. So this way you can write this tabular format. You can write individually, and then you have to circle a particular record, and you have to show this is said to be a record. Likewise, individually, the records will be separated, and you can show that as an example. That is a memory representation. And how the record will be different from the linear array, that these points you can write. So generally, this will be a 3-mark question. Sometimes everything will be collected together when will be asked for the 4 marks, like what is record, memory representation, and how it has been different. So everything you have to write. Generally, this record memory representation, it carries 2 marks. So the diagram you have to explain in detail. Diagram and as well as explanation consist of 2 marks, and the record definition is 1 mark, and this difference is for 1 mark, right? Next is linked list, tree, and then stack and queues. So again, if you see, linked list is said to be a linear data structure, right? So what does linked list means? You have to write linked list is a linear data structure, or you can say linked list is said to be a linear collection of data elements. So the entire data has been collected in the format of a node. The entire data has been collected, and it has been stored in the format called node. Node, there are 2 parts. One is what? Information, and the other part is said to be the link, that is address. Address for the next node. See here in this example, this is the syntax, this is the structure for the node. right? Information and link. Information is nothing but the value of that particular element, memory location value. And link is said to be connected with the next node, connected with the next node. So there will be a starting memory location, right? The starting memory location, it will be connected with the starting node. And here, say suppose here there are some values. Say suppose here is this visible whatever I'm typing? Hello, please give me a message in chat if you can able to read it. Okay, thank great. So starting node, say suppose starting node is equals to 100. This is said to be the memory address, right? So here the memory address is equals to 100, and here the memory address, say suppose the memory address equals to 102, and here the memory address means the node memory address. These things you need to specify, otherwise it won't be considered as a node, because address is very important. After completion of this, you just take a pic so that it will be helpful for you. Right. So these are this is the starting node which consists of 100, that is the starting memory location node address. So it will be connected to this particular memory location. This memory location is having a value called A, and this link will be having a value of this 102. 102 will be stored in this particular place, right? Right, 102 will be stored here. That is the link for the next memory location, next node. Likewise, each and every node, the link part will be the address of the next node. So each and every node, there will be two values. One is information and the link. Information is said to be the value which will be retrieved from the particular memory location, and link is said to be the memory location which is connected to the next node. This, sir, information, the memory location, or the data at the specific memory. Right, is it clear now, or have any doubts? Fine. So if you don't have any doubts, this is how the representation will be there, right? As I told you here, this is said to be the information, and this is said to be the address for the next uh, node. Okay. Have you taken the picture of this? If not, just take a print screen. Right. So let's see this how this it will be stored in the memory. So there will be a possible question like explain what is linked list and explain the memory representation of the linked list. So you have to explain with a small example. You can take any random example, but it should be with the proper memory address and the proper values, right? That memory address and the values that you have to split into two parts, information and link. See, this is the set of linked list, right? So this is the set of linked list. So this entire linked list has been divided in terms of information and link. So information is a separate array and link is said to be a separate array. Right here, a different example has been represented. Right, the start node is said to be the node number 9. Right, so it will directly connect to this particular place. Right, n, the value which you will obtain from this memory, it is n, and the n ka link is what? The link for n is what? 3, right? The link for n is what? 3. The link for n is 3. So from this 3 it will redirect to this third node. So here in this third node, you will take the value as O. That is, first you got N, and second you got O, and from here it will connect to node number 6. So 6 it will be blank space, right? And from 6 it will be connected to node number 11, and 11 it is E, right? So it will display E, and it will connect to the node number 7. So 7 it is X, it will connect to the node number 10, and in 10 it will take the value as I, and it will connect to node number 4, and in node number 4 T will be taken out and it will be connected to 0. 0 means what? Null. That is termination. Actually it is /0. You have to write /0 to terminate it, right? So this is how the memory will be maintained, and this is how the access of the value with the help of linked list will be executed. So when you're executing this type of values with the help of linked list, this is how it will execute. So starting it will go to the node number 9, and from it will go to node number 3, and it will go to node number 6, and from 6 it will go to 11, and 11 to 7, 7 to 10, 10 to 4, it will stop the process. So as per this execution, the sequence of step, what all you are getting, if you see, first it is n, and second one is no o, so that is no, and then space, then exit, no exit. So this is what the word you are retrieving from the particular memory locations, no exit with a space. So that is what you are getting from this memory location. Got it? Any doubt?
No, sir.
Okay. Next is tree. So the linked list, as I told you, it will be a 3-mark question, right? So you need to explain this, what is linked list, and the example with this memory representation format, it will be a 2-mark. Next, tree, coming to the last part of this data structure. This topic is very, very important, tree. From this, definitely a 4-mark question or a 3-mark question going to come. You have to draw the tree structure, right? So please listen carefully. It is very simple, but most of the students, they do mistakes with the levels and they do mistakes with the drawing structure, right? It should be proper as per the structure, and it should be followed by the methodologies, proper methodologies. Let's see. Tree, first of all, tree is said to be a non-linear data structure. Non-linear data structure means what? Non-continuous. It is stored in different places and it can be connected with a small link, right? So the types of trees, there are many types of trees. One is null tree. That means what? If the tree is consisting no nodes, so then it is said to be null tree. Binary tree, that means what? Tree consisting of two nodes, it is said to be binary tree. The left side is said to be a node and right side is said to be a node, and each node will be considered as a tree, that is left subtree and right subtree. Ordered tree, children of each node are ordered from left to right. Everything it is ordered from left to right, then it is said to be ordered tree. Non-ordered means it is the nodes are not ordered. See this example. These are the things that you need to write. This is the parent node. A is said to be the parent node, and B or C is said to be the child of this parent. And likewise, siblings and everything, it will go level by level, right? So this is the first level, and second level, third level, fourth level. So whenever you are drawing diagrams, the levels has to be maintained properly. And as it is a binary tree, as it is a binary tree, the node which will not consider or which will not having more than two nodes, right? See in this example, B is consisting of D and E. There are only two nodes. Same way, D is consisting of H and I. C consisting of F and G. So it's not more than three nodes, more than two nodes, right? If you are drawing three nodes, then that means that is wrong. The entire tree will go wrong and you will not get marks. In this tree diagram type of questions, if you make any one small mistake, the entire mark will be lost, right? So please do it carefully and please listen this lecture carefully. Right, so how the nodes, as I told you, how it will execute. Parent child nodes. So this child nodes will be taken as what? Left child and right child, left child and right child, right? So execution mostly, if you see, left parent and then right, left parent and right. So this is the normal methodology of execution with the help of binary tree. There are two more methods. One is pre-order and the other one is post-order. This is left, this is right, and this one is parent. So there are three orders. One is in order, in order, pre-order, post order. So in order is nothing but, this is all I'm talking about, the level of executions, how this will execute, right? So in order means what? It will start execute L, that is left node, and then parent, and then R. Okay, left, parent, R, right node. If it is pre-order, parent, left and right. First parent node will execute, then left and right. If it is a post order, left and right will execute first, then it will followed by post order. Always parent node, always this parent node is equals to an operator. It should be an operator. Say suppose here I am taking an example a plus b. So this is an expression, right? So generally this tree is used to draw and see how the expression will be executed, how the expression will be stored, and how the expression will be executed, right? That is the use of tree. See, suppose this is a small example of expression, how it will be stored in the memory. If you see, so this is said to be the parent node. This is A, and this is said to be the sorry. This is said to be the parent node, and this is said to be the left child, and this is said to be the right child. So this is how the nodes will be maintained, right? And how the values of this expression will be stored. If you see, as I told you, parent node will be the operator. So this is the operator in this expression, and left side of this expression is A, and right side of the expression is 3. Example A plus B. So as I told you, parent node will be the operator. This will be the operator, and A will be the left side node, and B will be the right side node. And this it will be connected with the here when you are drawing lines, don't put arrow, right? It should be simply line. And when you are drawing line in the linked list, you have to mention the arrow. So this is how it is maintained in the binary tree. And the level numbers are nothing but this is the first level and this is the second level. So there are two elements, right? So there's a formula to find out the number of elements in the binary tree. That is 2 to the power n minus 1. So if the here n is said to be what? N is said to be the number of levels. N is said to be the number of levels, and the formula is set for to find out the depth of the tree. To find out the depth of the tree, you can use this formula, that is 2 to the power n minus 1. So if you see here, the level is said to be what? 2. So number of depth of the tree is what? 2 to the power 2 minus 1, that is 2 to the power 2, 4, 4 minus 1, 3. So 3 elements will be there. So there will be a possible of one MCQ. They will mention the level also, and they will ask the maximum number of elements in that particular level. Say suppose they will mention if the binary tree is consisting of 6 levels, so what will be the maximum elements in that particular binary tree? So what will be the maximum elements?
32.
Very good. 2 to the power 6 minus 1, 31. Fine. So this is how you need to explain about the binary tree, the basic things. Have you taken the screenshot? So I'm going with the next one. Binary tree, it is continued with the same thing like whatever I have explained there. Same thing. It's a small example. So how this expression has been explained, how this expression has been explained with this binary tree. 3 plus 5 plus 9 multiplied by 2. So first the inner one will be taken. That is the primary thing. So that it will execute. So whenever you are drawing a diagram, you have to consider this BODMAS rule also. So whatever the operation will be considered as the primary and the first operation, that will be the operator of the root node, right? So here, if you see here, this is said to be the parent. Here you can separate two things. One is 3 and this, right? So here left hand side of this operator 3 will be the left child node, and right hand side of this operator is said to be the right subtree. So the entire thing is said to be left, that is 3, and this entire part is said to be the right, that is said to be right hand side. So over here this star multiplication is said to be the major operator, and uska left hand side will be considered as the left subtree, and this 2 is said to be considered as the right subtree, right? So if I go inside of this, right, here plus is said to be the operator, so plus will be the left subtree, and 5 and 9 will be the right and left subtree for this parent. See, first 3 and then major operator star, then from here it is plus, and from here 5 and 9 and then 2. So this is how the binary tree will be drawn, and this is how you need to explain with the example, right? So there will be a expressions will be given, that expressions you need to draw with the help of this binary tree concept, right? So while executing, how it will execute, as I told you initially, pre-order, post-order, and then in order. See here, it will start from this last level, 5 plus 9, that is what BODMAS, 5 plus 9, left order. I'm talking about the left order. Left, right, sorry, left, parent, and then right. And here you will get some value. Say suppose 14 you are getting. 14 multiplied by 2, that is 28. So 28 it will be stored in this place. 3 plus 28, that is 31. So the expression value, the result is said to be 31. This is how it will execute from the memory. So I'm relating this entire expression in terms of memory and as well as execution part. How it will be stored in the memory and how it will be retrieved from the memory for the execution. So yeah, so the representation of the memory. So the representation will continue in the next slot. Next slot means after 2 minutes. So till now, if you have any doubts, please let me know, clear your doubts. Then we'll continue with the remaining parts in the next 10-15 minutes. Yes, come on. Nobody's having any doubt. That's great, yeah. Right, 191163. Please unmute yourself and give me the answer.
Yes, sir.
Thank you. What is linked list? What is linked list?
Sir, a linked list or it is a linear collection of data elements,
Very good.
which are also called nodes,
Hmm.
and the order is given by pointers.
Very good. Very good. What are the two different paths which is available in node 191216? Please unmute yourself and give me the answer. What are the two paths which is available in node 191216? There are two paths. One is link and as well as information. Okay.